In this question, we're characterizing a horizontal hyperbola using some key features. I'm not given its equation. I'm just told what the vertices are, right, these guys, and one of the co-vertices. And actually, this is easier than the equation, and we'll see why. But the first thing I like to do, before I get into all the equation stuff, is just draw it, right? We're told these key features. Let's put those on a graph and see what they look like. And if you do that, you'll get the following picture. You'll get some vertices, and I put those in purple here. And -4, -5, 2, -5, those tell us that it's the x value that's changing as you go from one vertice to the other. And that means it's a horizontally oriented hyperbola. Okay, now we can get the center very easily by just taking the average of those two vertices. And I'll just do this graphically, but it looks like the center point is located at -1, -5. Right? And you could add those x values together and cut them in half, just like you would average two test scores. That's a fine way of doing it. Now, the next thing I'm told is that the co-vertex is located at -1, -7. Okay, well, that's down here. And if I look at that center point, I see I'm 2 points down from it, which means the other co-vertex must be here. And that's going to be at the following location. That's going to be, looks like -1 in x, and -3 in y. See, now we have almost everything we need about this hyperbola. We know that the, let's see, this is going vertically, so this b value is going to be equal to 2. That means b squared equals to 4. We'll use that in a moment. And we also know if you go horizontally between the two vertices, not b, the a value is equal to 3. That means a squared equals 9. Okay, now let's take those ideas, a squared and b squared, and put them up into this equation form right here. I'm going to have x minus h, but I want to get that a squared down before I forget it. I said a squared was 9, and I have y minus k over b squared, and I said b squared is 4. And the whole thing's equal to 1, because that's just how hyperbolas look. Now the center of this guy was located at -1, -5, so that means +1, that's the negative x1, and +5. Okay, right here. Remember where this came from. This came from the center being located at -1 in x and -5. Okay, so just point real clear where these go. That one went over here, and the y value of the center comes over there. Okay? Great. So now we've got the standard form equation. We talked about the center. Okay, we talked about these guys, these guys. We made the vertices and co-vertices kind of graphically. We need to know where the foci are located. And if you remember the equation of the foci, what that's going to look like, right, this little part right here, that's going to look like this. C squared equals a squared plus b squared. Remember, for a hyperbola, that looks like the Pythagorean theorem. So what do we get? We get c squared equals, well, a squared is 9, b squared is 4, so that's going to be 13, and then that means c equals the square root of 13. So we're going square root of 13 away from the center. Now, this is a horizontally oriented hyperbola, so I'm going some distance over here. Like, I don't know if this is accurate, but it's a pretty good guess. The foci are going to be located to the left and right of the center, even further than the vertices. So what we're going to do is we're going to take that center point, and we're going to add and subtract from the x portion of it that radical 13. So in this case, I say -1 plus radical 13, comma -5. That will be my first foci. And my second one would be -1 minus radical 13. And the y value doesn't change, of course, because it's a horizontal hyperbola. So there's my two foci. And the equations of the asymptote sometimes takes a little bit of thinking to get through, but I like to do it this way, because I'm pretty good at plotting straight lines. I can do that. So I'm going to make this graphing window right here, using the vertices and the co-vertices to orient myself. And now if I look at this first line going up and to the right, see how it's going up by 2 and over by 3? Well, that's your slope. So m for that curve equals, let's see, up by 2, over by 3. M equals 2/3. So now we say, okay, y equals mx plus b. And we plug in the values we know. One thing we know, we just mentioned, the slope, but we also know x. Okay, I know x for the center point, which that asymptote passes through. The center is located at -1, comma, -5. So it's going to be -1 in x, -5 in y, plus b. So if you solve this equation, you get -5 plus 2/3 equals b. -15, I don't know, -13/3, I think, when we solve for this guy. So that gives us this equation. Y equals 2/3, that was the slope, minus 13/3. Okay, that's our y-intercept over there. Okay, great. Let's try the next line. See, this one, it's going to be slightly different. This one's going to be going down and to the right. It's not perpendicular. It's just the negative slope, -2/3, right? It goes down 2/3. So in this case, m equals -2/3. And I plug it into the same idea before. Y equals mx plus b. And I use the center point. That's a very convenient point, which was x equals -1, y equals -5. The slope is -2/3, and there's my plus b. I'm going to figure out what b is, then I'll have my equation. So this becomes -5 equals 2/3 plus b. So that means -5 minus 2/3 equals b. And what's that going to be? -17/3, I think. Double check my math there, but I think that's -17/3 equals b. So we get the following. Y equals, in this case, it's -2/3. Remember, this is the line going down, times x, minus 17/3, and that's my y-intercept. Now, if you want, you can do a sanity check here, which means, do these equations kind of look reasonable at all? Well, the slopes make sense, and if I look at their y-intercepts, see this over here? There's one of the y-intercepts of the asymptote. Remember, it's not a real y-intercept, it's just the intercept of the asymptote. Those look like they're in about the right places compared to the equations. So that's how we fully characterize this thing. I think the key features are a real step up. If you've got one of those equations, it's not as bad as sometimes when you're given a messed up equation and you have to complete the equation first. Those key features tell us a lot of stuff about this picture that we need.